Hi all, welcome back to my lecture series. This is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see the topic on application of RS and GIS over crop acreage and water requirement estimation that comes under the subject Geographical Information System for the students of third year BTech Agricultural Engineering and fifth semester. Before going into the session, let us recap what we have seen in the previous classes. We have something about data structure analysis, data products, output scale, and spatial analysis. Today we'll see how the GIS has been transformed, what are the key challenges that we are gonna face, and what are the core problems and necessity for this application of GIS and RS. Let us explore because we do know that remote sensing is very important as it gives us accurate and sensible crop mapping along with the statistics on planning areas are fundamental requirements for effective agricultural management and policy making. The use of satellite under RS and GIS data has proven to be more cost effective ground based agricultural asset surveys, which are often subjective and prone to large errors due to insufficient ground observation. This is where this GIS and RS plays a major role because remote sensing allows for the acquisition of wide range of crop growth under dynamic information at real time. So this potential comes from the unique advantages of remote sensing techniques, which provides multispectral, multitemporal, and multispatial resolution for information on agricultural resource characterization and spatial distribution. So this is why we are prone to get upgraded with the RS and GIS techniques. So here, as I have said, I have shown you why it is important and why is it advantageous, because it gives us dynamic data with very accurate and efficient results, and also this results will be useful for the cost effectiveness. So now we can see what are the fundamental principles that is involved under vegetation indices by involving our design thinking topic, that is empathize. We do know that the main principle in collecting these data are for spectral signatures and vegetation indices. So usually these remote sensings rely on the distinct way of healthy vegetation reflects and absorbs energy across different wavelengths. So here is where the spectral signature near infrared reflectance come into existence, because healthy plants exhibit a specific spectral signature and the reflectance in the visible bands is relatively low because leaf pigments, particularly chlorophyll, absorb energy in the blue and red wavelengths while reflecting green, giving plants their green color. So here, as we have seen how the color gets changed, the near infrared reflectance, crucially for RS, the reflectance of healthy vegetation is much higher in the near infrared regions than in the visible region due to the cellular structure. So that is why the healthy vegetation can be identified by its high NIR reflectance and low visible reflectance. As you can see here, to quantify and map this difference, vegetation indices are used. So these are the mixtures of surface reflectance at two or more wavelengths designed to highlight the specific property of vegetation, which I have shown you as a mind map over here, because the spectral signatures usually help us to unique reflectance pattern of vegetation, and the near infrared reflectance is usually helpful for higher NIR reflectance due to the leaf structure, whereas vegetation indices will help us to quantify the measures of vegetation properties in a quantifiable manner. So this is where the NDVI came into existence, because it is a simple indicator of green biomass, where these use of NDVI could be used under crop identification purposes. NDVA is nothing but normalized difference vegetation index. It is a simple graphical indicator derived from these reflectance properties. It is used to determine whether the target being perceived contains live green vegetation. At any time, the NDVI is reliable indicator of the total green biomass. So these maps are produced from satellite imagery and can be introduced to algorithms such as multi-resolution segmentation algorithm to delineate agricultural fields. An NDVI based decision algorithm can then be developed to identify the specific crops devoted to each field. So, the methodologies that are involved for acreage estimation is the main definition under our step, that is boundary overlaying approach and sample segment approach. So, these approaches will help us to integrate the technology and data processing where we use the pestle method, that is the technology integration in agriculture is done with the help of government data access, cost effective monitoring, improved crop management, advanced data analysis, sustainable resource use, and then is the data privacy compliance. So these national programs will help us in calculation of acreage estimation. The government programs like Chaman, Kappe, and FASL will help us the to identify the remote sensing surveys, and this program will help us to build the data that are necessary for crop estimation. So this is what we have seen today. Let's summarize what we have seen. With the help of crop acreage estimation, we have seen what are the advantages, importance, what is the fundamental principle, what could be the remote sensing methodologies for acreage estimation, and we have also seen about technological integration and then the national programs that are available. So today's assessment question is, what fundamental requirements for agricultural management are provided for remote sensing? As you guys can see, I have given four options: crop mapping, statistics, surveys, and remote sensing. So the option is obviously going to be crop mapping because we have dealt today with crop mapping. So these are the references where I have taken the content, and if you guys want, you guys can go and see it, and if there is any kind of doubt or anything, you guys can ping me anytime. See you at the next class. Thank you.